This movie is for Unit 7, Learning Target 2. I can multiply powers with the same base. Multiplying powers with the same base. For every non-zero number a and its integer m and n, if I do a to the m times a to the n, you will notice you have the same base, so what you can do with the exponents is add them, m plus n. For example, x to the fourth times x to the third is x to the 4 plus 3, which is x to the 7th. And here is why. X to the fourth times x to the 3 means that I have 4x's multiplied by 3x's, giving me 7x's in total. That's why you get to just add the exponents. You have an exponent packet. I want you to pause this movie, complete page 2 of that exponent packet, then I want you to grade that page 2, then proceed back with this movie. We see in the exponent packet that x to the third times x squared gave us x to the fifth. We call this our factored form, this our exponential form. So in that exponential packet, here is what you need for the factored form, here is what you would write for the exponential form. Number 1, y to the third times y to the fourth. This is your factored form, where you have 7 y's being multiplied, and here is your exponential form. Go ahead and finish page 2 of that packet and then press play when you are finished. All right, let's practice this skill. Here we have 2 monomials being multiplied, in which case I'm just multiplying 3 times d to the negative 4th times 5 times d to the 8th. So I'm going to multiply my numbers. 3 times 5 I know is 15. And then d to the negative 4th times d to the 8th, I'm going to add those exponents, and negative 4 plus 8 gives me 4. Everything here is simplified. I don't have any negative exponents, so I'm going to circle that. This next one, I've got 1 over b to the third times b to the negative 4th. I'm going to add my exponents, and I get b to the negative 1. 3 plus negative 4 is negative 1. Before I circle that, I know that I cannot have a negative exponent, and the negative exponent tells me it's in the wrong location, so it travels to the numerator as b to the first. Number 3, we're just multiplying. There's no addition or subtraction, so I'm able to do 6 times 9. I get 54. I can do my r's because they have the same base. An r alone means that it has an exponent of 1. So I do 4 plus 1 to give me r to the 5th. S, I can add my exponents and I get 3 plus 2, which gives me 5. There are no negative exponents, so I'm going to circle that. Looking at 4, I'm just multiplying 3 monomials, and there's no addition or subtraction. So I'm going to do 2 times, the coefficient of this guy is 1, times 3, which is going to give me 6. With my a's, I've got a squared times a squared. So it's 2. This has an invisible 1 for a power. So 2 plus 1 plus 2 is going to give me 5. A to the 5th. Then for my b's, I've got a b to the first, b to the negative 1, b to the negative 2. 1 plus negative 1 plus negative 2 is negative 2. Now before I circle that, I see that I have a negative exponent. That tells me that the b to the negative second needs to go to the denominator. So I get 6a to the 5th over b squared. Down here, I've got 5 to the 8th times 5 to the x equals 5 to the 5th. These all have the same base. So that tells me that I know if I add my exponents, my 8 plus x, I will get 5. So I'm basically just solving this. So I'm going to subtract 8 and I get x is negative 3. So if I were to plug in a negative 3 here, 8 plus negative 3 does give me 5. And that's how you could solve this for x. As an application to this idea, we're going to look at scientific notation. For a number to be in scientific notation, the absolute value of the number must be between 1 and 10. There needs to be a multiplication sign, and then 10 to some power. So let's look at this number written in scientific notation. We are going to put our decimal in a place that makes it a number between 1 and 10 less than 10, 2.3. The second thing is a multiplication sign, And then the third thing is 10 to some power. Now the power is how many times you needed to move the decimal place. In this case, it needed to move 6 times. So it's 2.3 times 10 to the 6th. You'll see in the second example, this is a very small number. So the difference here is, I'm going to move my decimal to the right. So I get 4 times 10 to the, instead of doing a positive power, I do a negative power. And this is going to be a -4 because I move the decimal place 4 times. So a negative exponent is telling us we're dealing with a very small number, and a positive exponent is telling us we're dealing with a large number. Note, the power of 10 is decided by how many times you need to move the decimal point, not how many zeros you have. Also note, when there's a positive exponent, the number is larger. When there's a negative exponent, it gets smaller. So let's look at this first example, 9.89, or 7.89, times 10 to the 5th. That's a positive exponent, so I know this number is going to get larger, and I'm going to move this 1, 2, 3, 4, 5 places. So I need to add 3 zeros. I get 789,000. So again, the exponent is how many places you move the decimal, not how many zeros. Let's look at 6.7 times 10 to the -3rd. The negative tells me it's going to be a smaller number, so I'm going to move this decimal place to the left, 1, 2, 3. So it becomes 0067. Now let's apply that scientific notation to what we just learned. We're going to multiply two numbers written in scientific notation. And the way to do that is to multiply your number values. 2 times 4 gives you 8 times 10. Now 10 to the 6th times 10 to the 9th. They both have the same base, so we keep the base of 10 and we add the exponents, 6 plus 9. So that gives me 15. So I get 8 times 10 to the 15th. Let's apply that down here. Two numbers written in scientific notation. I'm going to multiply these two values. This gives me a positive 56 times 10 to the, now I'm going to take 11 plus -4, and that's going to give me 7. Now the problem here is I'm looking at this number 56, and that is not a number between 1 and 10 less than 10. So I want to create a number between 1 and 10 less than 10 by making it 5.6. Now I move the decimal one place, so what I have to do is add 1 to my exponent, giving me 10 to the 8th. So I get 5.6 times 10 to the 8th. Let's look at this one. We'll do -3 times 3, giving me -9, times 10 to the 8 plus -5 gives me 3. Everything looks to be in order. And the next one, we got 6 times -6 gives me -36 times 10 to the, and I've got -7 plus -4 giving me -11. Now -36, I need to move the decimal point one place, so I get -3.6 times 10 to the -10th. We're going to skip this problem and go right to rational exponents. Now we're going to dive into rational exponents later on in the unit, but these next few examples are going to follow the patterns that we've already seen. Exponents can also be written as fractions, and a rational exponent is just those fractional exponents. Let's look at this example. We're going to simplify this expression. It's got a rational exponent because of the fraction. So what we've got here is 2a to the 2/3 times 3b to the 1/4, a to the 1/3 times 5b to the 1/2. In your guided notes, that might look a little bit small. So there is nothing different in this situation other than here we're just multiplying all the way across. Everything's being multiplied. There's no addition or subtraction. And so I'm just going to multiply these. 2 times 3 times 5. So I get 6 times 5, I get 30. Now my a values, I'm looking at a to the 2/3 and then I've got to add 1/3. We know when we have the same base that we can add the exponents. So what I need to do is 2/3 plus 1/3. That's going to give me a to the 3/3, which is 1. The b value, I've got b to the 1/4, b to the 1/2. I need to do 1/4 plus 1/2. Now the key to this is knowing that you need to have a common denominator. When you add and subtract, you need a common denominator. So 1/4 plus 1/2, I'm going to make this 4. So I multiplied by 2 here, got to multiply by 2 there, so I get 2. That gives me 3/4. So it's really 1/4 plus 3/4, giving me 4/4, or sorry, 3/4. So I get b to the 3/4. Okay, so I get 30, a to the first, or just a, you can write it that way, 30a, b to the 3/4. So fractional exponents, the only thing you need to remember is that you need a common denominator to add them. And that's all for this movie.